Hi, my name is Jonathan Carter. I'm a program manager within Visual Studio, and today we're going to talk about some improvements that we've made to the HTML UI Responsiveness Profiler in Visual Studio 2013. And specifically, I want to show how we've made it even easier to identify the cause of performance issues related to resource loading, frame rate drops, and just responsiveness and lag problems that exist or could exist in your Windows Store apps written with JavaScript. So one of the first changes you'll notice in Visual Studio 2013 regarding the HTML UI responsiveness tool is that it no longer has its own unique menu item that requires you to launch it. In fact, the HTML UI responsiveness tool has been integrated into the Performance and Diagnostics Hub along with all other performance profilers in Visual Studio. So this is great because you don't have to worry about trying to chase it down in the UI or figure out exactly what entry point to use to get started. So when we come here and open up the Performance and Diagnostics Hub, you'll notice that because I've got a Windows Store app written with JavaScript project loaded, it immediately provides me with all of the options I would expect, including the HTML UI responsiveness tool. So let's go ahead and start a profile and take a look at some improvements that we've made to this tool in Visual Studio 2013. So we'll go ahead and run our app, start it, load it, get the UI rendered, and we'll go back and stop the collection in order to view the post-mortem analysis data. So some of the things that we wanted to do to improve the tool was make it easier to identify and resolve issues related to page load time, rendering costs, as well as general UI responsiveness issues. And so for instance, if we wanted to diagnose the cost and the time it took for this app to load and all of the things that contributed to that time, what we could do is utilize a few new features. One of which is on the ruler mark, you'll notice that we have a new application lifecycle mark that is called navigation. And so if we hover here, we'll notice that this is the point in time where the navigation occurred for this HTML file that represents our main page. In addition, the existing DOM content loaded and load user marks also indicate the URL of the page that they're responsible for loading or DOM content loaded respectively. So what this allows us to do is very deterministically know where in our profile the time that was spent that ultimately accrued to page load time and allows us to investigate that on a much more fine-grained level. So if I select this period of time and zoom in, and we can even keep going more and more fine, so we'll just make sure that we get as close to these marks as possible so that we don't have to see any noise in order to identify what were the resources that we had to load, what were their individual costs. Right? So here we have the navigation, here we have the load. Now in addition, another small improvement that we made is you'll notice that down here in the timeline details we tell you what the duration of time was for the selection that's currently made. And this is very useful because it allows you to compare when you've made improvements to see that you've actually made a tangible improvement. So here we can see that 146 milliseconds is the time that it took to load this page, which is pretty acceptable, but in general we can always look to see if there's any more bloat or any unnecessary work that we can streamline. Now a few other things that we've done is let's come down here, and as you might usually do, if we sort the timeline details by duration, and sometimes this view gets a little bit crowded and you want to optimize it for more space, so we've also made the detail pane resizable and you can ultimately get rid of it. So you can optimize for horizontal space here for the Gantt chart to get a broader, more rich view of your app's activity. So here we notice that at the very top of this event activity waterfall, we notice that one of the most expensive things that happened was 100 milliseconds roughly of HTML parsing. Now what's interesting is you might wonder and ask yourself, why would HTML parsing take 100 milliseconds of time? And what we did is we actually introduced another feature that if I bring the detail pane back in, actually allows you to inspect at a high level what the overall cost of an event and its children were. So in this case, we notice that the inclusive time of the HTML parsing was expensive itself, 101 milliseconds, but exclusively only around 8 milliseconds of that was actually spent parsing HTML. And so what that tells us is that it triggered some other events that were responsible for the majority of that time. And whenever you select an event that is capable of triggering other events, which is going to be DOM events, timers, HTML parsing, anything that can synchronously initiate another type of work, you're going to be able to see this donut chart that what tells us is you'll notice it's the inclusive time summary. And this is aggregating all of the children of this event and giving you an idea or a mental model of the type of things that need to be optimized in order to make this smaller. So if we come down to the detail pane of this event and hover over this donut chart, we'll notice that 92% of its inclusive time was actually spent evaluating script. If we notice that 7% was spent parsing HTML, not even a 0.5% was spent parsing CSS, and some DOM access occurred, and so forth and so on. And so what this does is it gives us a pretty quick overview of knowing, okay, if we want to make this faster, what we need to do is go for the lowest hanging fruit here, which in this case is mostly script evaluation. So if we go ahead and expand this HTML parsing event, we can confirm quickly that the donut chart that was telling us that the majority of time was script evaluation does in fact seem to be true. Because we can see each and every sub-resource that the page, in this case default HTML, loaded immediately in the application's lifetime and what the individual costs of them are. Now in addition, because each script and CSS file is divided into their individual amount of time, we can see that the one that was the most expensive was called localized data. In the name, you'll notice that now in Visual Studio 2013, we actually provide source navigation for a whole handful of events, including CSS parsing and script evaluation, which is great because when you're trying to make an optimization and you might not be immediately familiar with what a resource is, in this case, we don't know what localized-data.js is, we can select the file, and it immediately opens up that JavaScript file or CSS respectively, which allows us to know whether we need this or if we can defer it to a later time. So in this case, what we could do is we could trim 50 milliseconds or so off of the load time by going ahead and removing this file, since we now know that we actually don't need it, and it's causing the majority of time in our parsing. So in addition to optimizing page load time, another very valuable thing to optimize are just general responsiveness, rendering costs, and instrumenting your app in order to know exactly how long certain scenarios of interest are. Now in Visual Studio 2012 Update 2, when we initially released this tool, we already supported the notion of user marks, as you can see on the ruler here, which these correlate to the begin loading of the home page and the end loading of the home page. But in order to be cohesive and consistent with the other perf tools, we now support instrumenting your app using the performance.mark standard HTML5 API, as opposed to the MSWrite Profiler Mark API that we supported previously. So what we can do is, because we now have these marks and we want to drill in and investigate this scenario more, just like with the page load time, we can select this period of time, zoom in, and immediately see the most expensive events as well. So nothing new here. What is new is that in addition to the source navigation that we saw for script evaluation and CSS parsing, you'll notice that also script events as well indicate their source location. So here we see this timer event, which tells us that this timer called a callback function named runner that was immediate timer, and if we click this, you'll notice that it takes us to the source. In this case, this was a Win.js event. In addition, we also support the same thing for DOM events. So if we scroll down here, you'll notice that there was DOM event focus, which when we expand it, we also in turn see that this does take us to the source location. Now in addition, one other thing of correlation that we added to DOM events is each DOM event in the detail pane now tells you which DOM element was the target of that event. So in this case, we can see not only did a focus event happen that triggered a function callback named handler, but it actually triggered that event on a div whose ID or whose class name was this set of names. So in this case, we can pretty clearly see that this was a focus event on our list view, which allows us to have a more informed understanding of what's going on in the app. So in order to highlight a few other features that we added in the tool, let's go ahead and take a look at some of the more egregious and expensive events that attributed to this time period of loading the home page. So for instance, this paint time took 37.93 milliseconds. In the previous version of the HTML UI responsiveness tool, we didn't provide much more information about paint time other than that. But now, in Visual Studio 2013, you can actually break down the cost of a paint operation into understanding what was the most expensive portion of the paint. And so in here, what we can do is, as you'll notice, when we start expanding out the paint, we can see not only the dimensions and the origin of where the paint rect was, but each individual element and what area of it was painted. So here we see the div ID search box, our page control, and our footer, each of which tell us exactly how much time they took to paint, as well as associating them with the element, which once again allows us to make a more informed decision around how we can streamline the UI to make things render quicker if we needed to. In addition to paint time, we also do the same thing for rendering and layout costs. So if we go ahead and select this instance of layout and expand it, you'll notice that as its children, you see the HTML fragment tree that was actually laid out. So in this case, what we can do is determine that, hey, there was 1.41 milliseconds of layout time spent, and of that, what it was actually doing was laying out this page control. In addition, for elements that use a unique or interesting layout mode, we'll display that in the Gantt chart as well. So in this case, we tell you that this div was actually using the CSS grid layout, and that will help inform the cost as well as the behavior that the application took in order to lay it out. So in this case, you can see that as the layout and the page fragment gets more complex, you'll begin to see that we'll show a very fine-grained view of the elements that were laid out or calculated for CSS so that you can figure out exactly where you can or want to make optimizations. Now finally, in addition to layout and paint being subdivided into a more precise time, we did the same thing for DOM calls. So if we come here and expand out this script evaluation, you'll notice that here it has a DOM event loaded that was for the script. And if we expand it out, you'll notice that as a child of it, we show now, in addition to just rendering costs, paint costs, image decoding, we're now showing also all of the DOM calls that were made as well as the associated element for them. So in this case, you can see that there was a call to document.createElement, and then there was a call to insert before on the div whose class name was this, the list view. Then another call to create element, then another insert before, and so forth and so on. And what this helps inform you is it lets you see and understand the exact activity and behavior of the application, in which case this was the list view being built up. Now, even more interestingly enough, is because we show the DOM calls inline in the details view, if a DOM call was responsible for synchronously triggering a layout, we'll also show that interaction as well. So for instance, if we scroll back up, you notice that here was an instance of calling inner HTML on the element whose div, it was a div who was the list view, and as a consequence of calling that inner HTML, we notice that that triggered parsing, as you might expect, right? If you pass a string of HTML to the inner HTML property, it has to parse that. But in addition, if the consequences of calling an API was triggering CSS calculation or layout, that is also very valuable to know. And so you'll see that the tool helps you see that in this instance, calling append child on the page control ultimately made it necessary to calculate the CSS for the page control. And so here you can see that the level of accuracy that is displayed in the UI responsiveness tool in Visual Studio 2013 is high enough to make it possible to narrow down exactly what the problem might be in your application. Whether it's script, whether it's resource loading, whether it's rendering, paint time, any of these types of CPU utilization, we wanted to make sure that you had the data necessary in order to spot the actual optimization technique that you would do.
So as we saw in the demo, whenever your Windows Store app written with JavaScript has a responsiveness issue and you need to understand the exact cause, the profiling tools in Visual Studio will help you identify whether it's script, whether it's rendering, what the specific DOM element is, and ultimately correlate that cost back to application code that will help make it actionable and resolvable for you. In the end, that'll make your apps even more performant and your customers' experience even better. If you want more information on this tool, please check the resources, which will include videos, blog posts, and other information to help continue getting started using this tool to improve your applications.